So with this problem, one of the issues that people run into is that they don't know how to identify what is an actual yield, what is a theoretical yield. They don't kind of know how to go about doing the problem. So let's really quickly walk through this. For the reaction between lead 2 nitrate and potassium chloride, 15 grams of lead 2 chloride is needed. So this 15 grams here is how much lead 2 chloride I need at the end of the reaction. And then the problem goes on to say that there is an 87.5% yield, which means that this needs to be my actual yield. The 15 grams of lead 2 chloride that I end up with needs to be how much I actually end up with at the end of the reaction, given that the reaction has an 87.5% yield. Determine the mass of lead 2 nitrate needed. So that's a reactant. That's this reactant here. And I'm given information about lead 2 chloride. Okay, so one of the things that I'm going to ask myself is, all right, is my wanted compound the same as my given compound? And in this question, the answer to that is no, it is not. So I know that somewhere in this problem, I'm going to be doing a molar ratio to go from moles of PbCl2 to moles of PbNO3 taken twice. Okay, and then from there, I need grams of lead 2 nitrate, so I can just use molar mass. And here you can see I've already calculated the molar mass for the compounds that I'm going to need. And then I'm going to get moles of PbCl2 from grams of PbCl2 using molar mass. And I'm going to, now this grams of PbCl2 needs to go into stoichiometry. And so we talked before about what comes out of stoichiometry is a theoretical yield. That's how much you should get in theory if you assumed a 100% yield, which means that these grams of PbCl2, this needs to be a theoretical yield. A theoretical yield, because if what comes out of stoichiometry is a theoretical yield, what should go into stoichiometry should also be a theoretical yield. But I don't have that. I have the actual yield of PbCl2, which I can get to grams of theoretical using percent yield. So that's where I'm going to start. This is my plan. Okay. I'm going to use percent yield to go from the actual mass of PbCl2 to the theoretical mass of PbCl2. And then I'll take that, put it in dimensional analysis, and go from grams of PbCl2 to grams of PbNO3 too. So I'm going to start by writing my equation. So percent yield equals actual over theoretical times 100%. And then isolate the variable that I'm trying to solve for. So I'm going to multiply both sides by theoretical yield. So I get theoretical times percent yield equals actual yield times 100%. And then divide both sides by percent yield. So theoretical yield equals actual yield times 100% divided by percent yield. So that would be 15.0 grams of PbCl2 times 100% divided by 87.5%. And when I do that math, I get 17.1429 grams PbCl2. That makes sense that my theoretical value should be greater than my actual value because I'm going to lose some because there's only an 87.5% yield. Okay, so now I have my grams PbCl2, so now I can do my dimensional analysis. All right, now because I have a mole ratio, I need a balanced chemical equation. I said that this one was n-balanced, so I've got to go back and balance my equation. If I put a 2 here to balance the chlorines, then I need a 2 here to balance both the potassiums and the nitrates, and that one's done. Now I can come back to my dimensional analysis setup, and I can put numbers in. And now when I do this, my answer is 20.4166 grams PbNO32. And I'm going to go back and I'm going to check how many significant figures I need. The percent yield has 3 in it. The actual yield has 3 in it, so that's going to be my least number is 3. So my answer should have 3 significant figures.